So effort and power of a porter governor. The effort and power of the porter governor may be determined as discussed below. So let n, right, so this is going to be the equilibrium speed corresponding to the configuration. Okay. For this configuration, the equilibrium speed is going to be 10. Right? So at n speed, this is at equilibrium. And C, the percentage increase in speed. C is the percentage increase in speed. Okay. So if the C is percentage increase in speed, the increase in speed is equal to C into n. C percentage into the equilibrium position n, that is equal to increase in speed C into n. Right? So increase in speed is Cn, which means the increased speed or final speed is equal to n, right? Equilibrium speed n plus increased speed Cn, right? N plus Cn, right? So the final speed or increased speed is n plus Cn. All right. So when you take n out, you will have n is equal to n into 1 plus c. Okay. The equilibrium position of the governor at the increased speed is shown in this figure. Right. So this figure is at increased speed, and this figure is at equilibrium speed. Right. So using a position of equilibrium speed and position at increased speed. All right. Now we'll bring it into the formula. We know for a water governor, the height h, right? The change in height h equal to small m plus capital M by m into 895 by n squared. Right? Small m is the mass of this board. Capital M is mass of the central load or central load, this one. And n is the equilibrium speed. Right? Assuming this angle alpha and beta are equal, right? So otherwise we will have 1 plus q here, right? So that q is equal to 1 because we don't need the complex portion here now, for now, right? So consider alpha is equal to beta, which means q is equal to 1. So what we will be having is small m plus capital M by m into 895 by n square. Right? If alpha is not equal to beta, then we will be having a 1 plus q here. All right. So we know this is the equation for a porter governor. So at equilibrium speed, this is a condition. Why? Because we use n here. What will happen when at the increased speed? So increased speed, the speed is n into 1 plus c. Okay. When the increase of speed takes place, a downward force P will have to be exerted on the sleeve in order to prevent the sleeve from rising. So we know when the speed increases, the sleeve will move upwards. In order to prevent the sleeve from moving upwards, we will be having to restrict it by giving equal amount of force. So that force is the P. If the speed increases to 1 plus c into n, so this is the final speed what we have seen so far, 1 plus c into n rpm, and the height of the governor remains the same. The load on the sleeve increases to capital M1G. Right? So if there's a change in the speed, right, there should be a change in the mass also, right? So that's what mentioned here, M1 into G. And therefore, we can write this equation of the porter governor to this position, to this new position. Okay. So H is equal to small m plus capital M1 into M1 upon M into 895 upon 1 plus c whole square into n square. Right? Why 1 plus c whole square? Because that's the new position after the increased speed. Right? So this is a new speed. So now we have two equations. Right? Two equations. One equation H at the initial or equilibrium position. That is small m plus capital M into n by upon m into 895 by n square. Now we have other equation for speed n plus n into 1 plus c. So this is a new speed n into 1 plus c. For that speed also we have h, right, which is equal to m plus capital M 1 upon m into 895 by 1 plus c whole square n square. Right? So why there's an m1? Because we have to change any one of this so that we can change the speed. Right? Equating this equation 1 and 2, we have an equation here that is for h small m plus capital M upon m into 895 h square, n squared. We have another equation here for h small m plus capital M1 by into 895 upon 1 plus c whole square upon n squared. Right? So equating these two equations, we have h here, we will equate it. So we leave that m plus capital M, rest of the terms are equal, right? You see here, m plus capital M, 895 upon n squared m we have. Here m plus m1 into m, 895 upon 1 plus c whole square m squared. Right? So when you equate it, you will be having m plus m equal to m plus m1, right? This 895 and this m would be cancelled out with this 895 and this m. So what we will be having is m plus m 1 upon 1 plus c whole square, right? Right. When you solve it, we'll be having m1, right? So we need m1 to be subject. M1 is equal to capital M plus small m into 1 plus c whole square, capital M plus small m into 1 plus c whole square, minus m, right? Minus m. Okay. Further solve it, capital M1 minus m, capital M1 minus m equal to m plus m into 1 plus c squared, right? M plus m into 1 plus c squared minus m. Minus m, I am subtracting minus capital M from both the sides. Okay, m1 minus m, right? M1 minus m, and this term minus m. Okay, so small m plus capital M into 1 plus c squared minus m minus capital M. Okay, I am subtracting from both the sides. When you arrange it, you will have small m plus capital M. Here also I have small m plus capital M. If I take this minus outside, I will be having minus small m plus capital M plus small m plus capital M. Here I have small m plus capital M. If I take these two out, I will have small m plus capital M into 1 plus c whole squared minus 1. Okay, 1 plus c whole squared minus, there's a minus m plus capital M. If I take this also out, what will I have? Plus minus 1. Okay, so this is the equation we will be having. A little consideration will show that capital M1 minus mg is the downward force, right? So we'll consider this m1 is the new mass, m is the old mass. Multiplying it with g will give you the weight, which is the force. Right? Is the downward force which must be applied in order to prevent the sleeve from rising at the speed increases. Right? So if the speed increases, we know the sleeve will rise up. In order to prevent it from rising up, we have to apply this amount of force. Which amount of force? Capital M1 minus capital M into G, this amount of force. It is the same force which acts on the governor sleeve immediately after the increase of speed has taken place and before the sleeve begins to move. Right? So when the sleeve is about to move, this force will apply. Right? When the sleeve takes a new position as shown in this figure B, right? So this is a new position, right? At this position, this force gradually diminishes to 0. Right? So until it takes this new position, that force will apply. Once it reaches that position, that will be 0. Let P the mean force exerted on the sleeve during the increasing speed of the effort of the governor. Right? P will consider it as a mean force, right? Mean force exerted on the sleeve during the increasing speed. Right? So during the speed increases from this to this, the position of the position changes. Right? We'll consider that P or the effort of the governor. Right? So we'll consider it as the effort of the governor. P is the effort of the governor. Okay. So P can be written as M1 minus M by 2 into G. Why is that? M1 minus M into M, right? M1 minus M into G. This term is the force which needed to prevent the sleeve from moving up. Okay. Capital M1 minus M into G. Why I am doing this 2? Because we usually do calculation for only half the part. So this is right half of this question. Right? So only half part we are doing. So there's another half which we usually don't consider, right? So the equation of it. Okay. So M1 minus M into G by 2. Alright. And replace with this term, okay, this term, small m plus capital M into 1 plus c whole squared minus 1. Okay? Small m plus capital M into 1 plus c whole squared minus 1 into g by 2. Okay. When you solve it, small m plus capital M into 1 plus c whole square. So I'll open this bracket 1 plus c whole square. So that is 1 plus c square plus 2c, and this minus 1 into g upon 2. Okay. I'm just opening this bracket. When you solve this, we have plus 1 and minus 1, which will be cancelled out. And c square, we will neglect this term from here onwards. This c square, why? Because it is so small. We know this is a fractional change in the speed, right? Fractional change. Even if we assume it is 1% change, right? 1% change, which means 0.01. Okay, let's assume 10% change, which means 0.1. Right? If the 10% change is 0.1, right, then the square of it, c square, that is 0.1 squared, that is 0.01. So when you consider these big terms, 0.01 is a small term which you can neglect. Okay, so that's why we neglect this c square. Okay, so this 1 and minus 1 will be cancelled out. This c square will be neglected, and we will be having only 2c in this bracket. This 2c and this 2 will be cancelled out, so we will be having only c, which means small m plus capital M into c into g. Right? So we come down to this point. Okay? If F is the frictional force in Newton at the sleeve, then right, if F is the frictional force, so we so far didn't consider the frictional force. Now we are going to consider frictional force also. So under such circumstances, P will be equal to C into small mg plus capital Mg plus or minus F. This plus or minus F will be the frictional force depending on the motion of the sleeve. Right? If the sleeve move upwards, the frictional force would be downwards, right? Which will be added. Why? Because Mg and frictional force are on the same direction. If the sleeve is moving downwards, the frictional force would be upwards, which is opposite direction to the Mg. So there we will use Mg minus F. Right? We have already discussed the power of the governor is in the product of governor effort and the lift of the sleeve. So far we have found the effort of the governor P, which is equal to C into capital M plus small m into G. Now we are going to find the power of the governor. Power of the governor we have already discussed that it is effort into the distance of sleeve movement. Okay, so power P, governor power is equal to P into X. Right, X is the lift of the sleeve and P is the effort. Okay, if the height of the governor at speed N is H, and at increased speed 1 plus Cn, it is H1, right? So now we are going to see two circumstances, two incidents. At speed N, the height is H. At 1 plus C into N, the height is H1, right? So we'll write the equations for these two conditions, right? Then X is equal to 2 into H minus H1. Why 2 into H minus H1? Because we know that change in height is H minus H1. Okay, we have two sleeves, right? One upper sleeve and one lower sleeve. So 2 into change in each of these sleeves, H minus H1. Okay. So we'll write the Porter-Governor equation first. H is equal to small m plus capital M by M into 895 M squared. Right. This is for speed N. And for increased speed, there is 1 plus C into N. So instead of this M squared, I will put 1 plus C into N whole squared. Okay. So H1 is equal to small m plus capital M by M into 895 by 1 plus C whole squared M squared. Okay. So when you solve it, you will have H1 upon H, right? And bring it down, H1 upon H. So all these 895 M squared will be cancelled out. What you will be having is H1 upon H is equal to 1 upon 1 plus C whole square, right? All these M plus M will be cancelled out. This M will be cancelled out. 895 will be cancelled out. N squared will be cancelled out. So what I will be having is only 1 plus C whole square, right? So So h1 upon h is equal to 1 upon 1 plus c whole square. From here, we can make h1 as the subject. So h1 is equal to h upon 1 plus c whole square. Okay. So now we have found the h as well as the p. So we will apply it in this equation p into x. Okay. X is equal to 2 into h minus h1. So we have h1, 2 is a number, and p we have already found, p into mg plus ng minus f. Right. So we'll substitute these all terms in the equation which we have already found. So x is equal to, right, x is equal to 2 into h minus h1, right? 2 into h minus h1, that is equal to 2 into h minus h1. So h1 I have h upon 1 plus c whole square, right? H minus h upon 1 plus c whole square. When you solve it, 2h, right? I'll take this h outside, 2h into 1 minus 1 upon 1 plus c whole square. Okay. You can further solve it, right? 2h into, I'll bring it here, so 1 plus c whole square minus 1 upon 1 plus c whole square. Right? So when you open this bracket, 1 plus c squared plus 2c minus 1 upon, I'll open the bracket, 1 plus c squared plus 2c. Right? So we'll take this here, multiply with 1 minus 1 upon 1 plus c whole square. Okay. So 2h into this plus 1, this minus 1 will be cancelled out. Okay. And this c squared again, it's small term, so we are neglecting, right? Same reason, it's a percentage. So when it when you take it into square, then it will be even so small, so we can neglect it. So this c squared and this c squared will be neglected. So what I will be having is this 1 and this minus 1 will be cancelled out. This c squared neglected, so I have 2c here and 1 plus 2c here. Okay. So x is equal to 2h into 2c upon 1 plus 2c. Alright. Substituting the values of p and x in equation 5. Here we have the equation 5. Down above p into x. P I have some value here. X I have some value here. So we'll replace it. So that is equal to p. First p is equal to c into small mg plus capital MG plus or minus f. Right? Small mg plus capital MG plus or minus f into this one, 2h, 2c, 1 plus 2c. Okay. 2c, 1 plus 2c, 2h. Okay. When you solve it, 2h into 2c into c, right? So 2 into 2, 4, c into c squared, so 4c squared upon 1 plus 2c, okay, into m plus n, into m plus n, into g into h, okay, into g into h, right? So here at this point, we didn't consider the friction, right? We didn't consider the friction at this point, okay? If we consider the friction, then friction will also appear either plus or minus f. All right. So for now, we put it in this formula, p into x. Right? P, I put only c in the mg plus mg into x, 2h into 2c upon 1 plus 2c. Okay. So this is a Gauss power, that is 4c square upon 1 plus 2c, small m plus capital M into g upon h. We can further solve it based on some conditions. If alpha is not equal to beta, right? At the initial stage, I told you we'll consider alpha is equal to beta. Why do I do that? Because I want to eliminate this 1 plus q part here. Otherwise, what will happen? I have to carry this 1 plus q throughout this, which will be difficult to solve this. So once we solve it, we can replace it with 1 plus q. So what will happen? If alpha is not equal to beta, then tan beta by tan alpha is equal to q. Right? This we already know. So at this point, what will happen? Here we have a 1 plus q. So h is equal to m plus capital M by 2 into 1 plus q upon m into 895 by n squared. Okay. And For increased speed, that is 1 plus c into n. Similar thing here, m plus capital M by 2 into 1 plus p upon m into 895 upon 1 plus c into n squared. Right? Okay, so this is a note if in case alpha is not equal to beta. Right? We could have done it earlier also. Right? If we consider alpha is not equal to beta here at this point, I have to have 1 plus q here. Okay, then I have to take that 1 plus q throughout these steps, right, which I don't want to do. Right? So once we arrive at the final equation, right, once we arrive at the final equation, it's easy if you can replace it to solve or substitute. Okay, from equation 8 and 9, right, these two equations, now we are going to solve it with alpha not equal to beta. Okay, so we are going to have this 1 plus q here. Okay, so this is h, this is h. We are going to equate these two. That means m plus capital M by 2 into 1 plus q is equal to m plus capital M 1 by 2 into 1 plus q, capital M 1 by 2 into 1 plus q into 1 plus c into n squared. Okay, so this n squared and this n squared will be cancelled out. This m and this m will be cancelled out. So I'll be having m plus capital M by 2 into 1 plus q equal to m plus capital M 1 by 2 into 1 plus q into, not into, upon 1 plus c whole square. Okay, so when you equate these two, you will get this. Okay, now we'll rearrange. Okay, now we are going to just rearrange to bring it to some easy form. m1 by 2 into 1 plus q, right? m1 by 2 into 1 plus q, I'm making it as a subject, equal to, I'm multiplying this entire part with this 1 plus c whole square, right? So m plus m by 2 into 1 plus q into 1 plus c whole square, right? I'm multiplying it with 1 plus c whole square minus this m, right? Because I made only this part as a subject, m1 by 2 into 1 plus q. So there's an m, so which means minus m, okay? Minus m. I'll open the bracket, m1 by 2, okay, m1 by 2, and I have m1 q by 2. I'll take it to the other side, all right? M into 1 plus c whole square. So I am breaking this bracket and bringing this 1 plus c squared inside, okay? M into 1 plus c whole squared upon 1 plus q. So I'm bringing this 1 plus q to downside, okay? So this 1 plus q is coming here, okay? This 1 plus c whole squared is going in, okay? So small m into 1 plus c whole squared upon 1 plus q plus capital M by 2, right? Capital M by 2 into 1 plus c squared, right? I'm breaking the bracket, so into 1 plus c squared. There's a 1 plus q, and I'm bringing down this 1 plus q, so that 1 plus q and this 1 plus q will cancel out, right? So there's no 1 plus q. Minus m, I'm bringing down this 1 plus q, right? So minus m upon 1 plus q, right? Now I am subtracting minus m by 2 from both the sides, okay? So here m1 by 2 minus m by 2, and this side from entire this term minus m by 2, right? This term is same, m into 1 plus c whole squared upon 1 plus q plus m by 2 into 1 plus c whole squared minus m upon 1 plus q minus m by 2. So this is minus m by 2, this is minus m by 2. I'm subtracting an m by 2 from both the sides, okay? So I can further solve it. Capital M upon 1, sorry, small m upon 1 plus q, m upon 1 plus q into 1 plus c squared, okay, minus 1 by my 1, this m plus 2 we have taken out, okay? M upon 1 plus q, right? M upon 1 plus q into 1 plus c whole squared, right? Into 1 plus c whole squared minus 1, right? Minus this term m upon 1 plus q, right? Plus, so this term is here, capital M by 2 into 1 plus c whole squared minus this m by 2, 1 by 2. m by 2, right? So when you open this bracket, you can see m by 2 into 1 plus c whole square, that's here, right? M by 2 into 1 plus c whole square. M by 2 into 1 minus 1, that is minus m by 2. That term is here. So this term is there, this term is there. When you open this bracket, small m upon 1 plus q into 1 plus c whole square, small m upon 1 plus q into 1 plus c whole square. So this term is there, minus, open the bracket, m upon 1 plus q, that is m upon 1 plus q, right? So I just rearrange these two terms in this format. Why did I do that? Because I have a 1 plus c whole squared minus 1 here also. I have 1 plus c whole squared minus 1 here also, right? Which means I can further condense this one, right? So I'll take this 1 plus c whole squared minus 1 outside from bracket for both. So what I will be having, m plus 1 upon q plus m by 2 whole bracket into 1 plus c whole squared minus 1, right? So these all are simple mathematics to arrange it to bring to a certain format. Right? Now governor effort P is equal to m1 minus m upon 2, the same thing, okay? The same thing. I'm just replacing here m1 minus m upon 2 into g, right? Governor effort, that's it. You see here, m1 minus m into g, right? So m1 minus m into g, and by 2 we are dealing only with the half of the part, right? So now I am going to substitute for this term m1 minus m upon 2. I am going to substitute for this term m1 by 2 minus m upon 2, right? Same thing, m1 by 2 minus m upon 2. So this is the purpose we rearrange this one, right, to bring into this format so that we can replace this thing here. Okay. So m1 minus m upon 2 is equal to small m upon 1 plus 2 plus m by 2. Okay. Small m upon 1 plus 2 plus m by 2. Outside the bracket, 1 plus c whole squared minus m minus 1. 1 plus c whole square minus 1. So 1 plus c whole square can be opened as 1 plus c square plus 2c, and there's already a minus 1 into g, right? This g. All right, this g. We can first solve it. Small m upon 1 plus q plus n by 2 into 2c into g. Why 2c into g? This minus 1 and this plus 1 will cancel out. This c squared is neglected. Why? Because it is so small. So what I will be having is only this 2c. Right? So m upon 1 plus q plus capital M by 2 into 2cg, into 2cg. Okay. So if I take this 2 inside, right, if I take this 2 inside, it will have 2m upon 1 plus q, 2m upon 1 plus q. This 2, if I take inside, then that 2 and this 2 will be cancelled out. So I will have only m into cg, into cg. Okay. So now the equation 6 for the lift of the sleeve becomes, okay, we'll see where's the equation 6. Yeah, here I have the equation 6. Right? So that is lift of the sleeve x, which is equal to 2h into 2c upon 1 plus 2c. Right? 2h upon 2c into 1 plus 2c. If I have 1 plus q here, right? 1 plus q into h into 2c upon 1 plus 2c. Right? 2c upon 1 plus 2c. Instead of this h, now I will have this 1 plus q also. Right? So h into 1 plus q. Why? Because we are dealing with if alpha is not equal to beta. Right? So we have to bring this 1 plus q. Right? So instead of h, I will have h into 1 plus q into 2c upon 1 plus 2c. That's normal. 2c upon 1 plus 2c into 2h. Right? But when we are dealing, if alpha is not equal to beta, then we have a 1 plus q here. Right? So I'll bring that 1 plus q in. So which means 1 plus q into h upon, into 2c upon 1 plus 2c. Right? And the governor power, right? So this is governor effort, this is sleeve lift. Governor power is equal to this into this, right? P into x. Right? So P we have 2m upon 1 plus q plus m, 2m upon 1 plus q plus m into cg at this term into x I have 1 plus q into h into 2c upon 1 plus 2c. Right? So if alpha is not equal to beta, this is a formula. Right? So here is the governor effort P, that is 2m upon 1 plus q into m, 1 plus q plus m into cg, right? 2m into 1 plus q plus m into cg into x, that is 1 plus qh into 2c upon 1 plus 2c, 1 plus q into h into 2c upon 1 plus 2c. Okay. So if alpha is not equal to beta, then this is the power of the governor. All right. We can solve it, right? This is a big equation, so we can solve it. 2c squared, 2c into this c, that is 2c squared upon 1 plus 2c into 2m plus capital M into 1 plus q. 2m plus capital M into 1 plus q, because this is entirely multiplication, right? So you can multiply it by just to bring it to a kind of format to arrange, right? So whatever is suitable for you, you can replace it, the numerical values at that particular time. But this is just a rearrangement. Okay. So 2c into c, that is 2c squared upon 1 plus 2c into, right, 2m upon 1 plus 2m plus m into 1 plus q. Why? Because this 1 plus q and this 1 plus q will be cancelled out. So 2m, there won't be any 1 plus q. This m into 1 plus q, right? M into 1 plus q into g into h, right? Into g into h. When you open the bracket, we have a 2m here. There's a 2c squared here. So 2 into 4, right? 4c squared upon 1 plus 2c within bracket. I have already taken this 2 out, so I have only m plus. I have taken the 2 there, but there's no 2. There is therefore m by 2 into 1 plus q into gh, right? So this is the power of the governor. All right. The above method of determining the effort and power of a portal governor may be followed by any other type of governors. Right? So the same format, same method can be applied to any other forms of governors. Right? So the same thing you have to do, just find the power, find the sleeve lift, substitute, and find the answer.